Hello. In this video, I'm going to show how to use SQLite in the browser using the origin private file system, and I'm also going to make this approach robust to deployment environments where cross-origin isolation is not set up by default, meaning that certain HTTP headers that you may not have control over are not going to read the correct value, and you'll need to override them so that you can opt into cross-origin isolation. So to get started, I'm going to create a Vite app. I'm going to go to my code folder, and then I'm going to do npm create Vite at latest. Just to keep things really simple, I'm going to use React and Bootstrap just so that I don't have to focus a lot on the setup or the styling of the app. So I'll call this SQLite, and I will use React, JavaScript, and I will cd into SQLite, npm I to install the packages, and then I'll open it in VS Code in a second. Now, SQLite has an official WASM or WebAssembly version that is supported, and the way that you can find that is search SQLite WASM and go to the official SQLite.org website. You can find from there the API reference and all the information, and also a link to the official npm module so that you get the right one. So I'm going to go ahead and install that. And I'm also going to install Bootstrap 5.3 just to make sure I have that when I go to use Bootstrap. So I'll do the Vite setup, just install Bootstrap and Popper, and then I'm going to install Sass as a dev dependency and use this particular version of 1.77.6. That's just going to avoid any deprecation warnings that can become pretty annoying. I'll just run that one last time. Sometimes I've had issues where things aren't updated exactly the first time. So I'll do code into dot, since we're in that folder. That'll open VS Code, and I'll bring that over and close the terminal, and then I can put this to the left and this to the right. Make this a little bigger and zoom in a bit. So let's just start the React app with npm run dev. And in my experience, the best way to work with SQLite in the browser is to use the suggested approach for, it's called the worker one promiser approach, and it has such a weird name because the idea is that they could potentially make other ways to make a promiser in the future, other ways to make a worker. Essentially, there's a lot of complexity that you may not understand depending on your expertise level, but the important things here are that we're going to be running WASM code. So SQLite, which is I believe written in C, was compiled down to WASM, and that's what's going to be running in another thread in the browser, and then we'll just be talking to that thread to do our database queries and such. And it's important that this runs in another thread so that it can access the origin private file system, which is going to allow it to do very efficient queries without having to write the entire database out at once. As that database would grow, it's important that you would be able to do in-place updates to the database like SQLite would do on your normal computer, as opposed to, for example, running it in memory and then saving the entire memory database to a file. That would be inefficient, and if the database got very large, it might not fit into your memory, or it might just slow down your application a lot. So it's important that we can use this worker one promiser approach. And I'm going to copy this baseline code, and then we will only need to make pretty small edits to get things working. So I'm going to just call it db.js. And some more configuration is required if you're using TypeScript, but in this project I'm just using JavaScript. And then in terms of Bootstrap, it's helpful to create one bootstrap.scss file and then pull in Bootstrap's Sass from this, or is it the SCSS file? Yes, here. And then we'll also need to pull in that into the project root, which I'm going to be using main.jsx. I can get rid of app because I don't want to use it, and I'll create my own function app that can return some just app text for now. And then I can go ahead and delete the app CSS and JSX, and I can delete most of the index CSS. Like I can delete the supported color schemes, and I can delete all of this stuff down here. Just gonna keep the font stuff. Actually, you know what? I probably don't even need any of this, but I could always come back and use it if I need to. So I'll pull in the Bootstrap SCSS file. So that would be in main.jsx. That would be a fine place to do it. So import /bs.scss, and then I'll also import Bootstrap's JavaScript so that it can run client-side JavaScript using import Bootstrap, just like plain Bootstrap, like that. So now we have its CSS and its JS. And now we have this app. So let's just say we want to add a Bootstrap class to do dark mode on the index. Here this would be called class rather than class name because it's just plain HTML. So the class would be, actually it would be just data set of BS theme equals dark. And we can tell that Bootstrap is somewhat working because that came in. I can also move the script up here and defer it. And I can get rid of this root here and just render main out of query selector for the body. Now, there's one other thing that we have to do when using Vite to make sure that the dependencies for SQLite aren't optimized in a way that impairs the functionality. So I'm going to copy over this configuration here from inside of the define config they mention on the npm page and just pull that into my config. And for now, I'm going to comment these out. Actually, I'm going to keep these commented out because these particular headers that are important, these two headers are what provide what's called cross-origin isolation. And cross-origin isolation is not provided through the headers by GitHub Pages at this time. So we need to employ a trick to make that happen. And the simple approach is essentially to download a script and bring it into our app, and it just creates a service worker that runs in the background. A service worker is different from a worker. It's something that can intercept HTTP requests, and so when we go and actually try to get the page itself, we can, first time we get the page with the wrong headers, and then the second time we go through the service worker and it actually tricks our document into thinking it has these certain headers. And that might sound like a hacky security flaw, but it's actually fine because these headers just let us opt in to a security restriction that we want to opt into so that we can use shared array buffer, which is used by SQLite in OPFS in WASM. So I'm going to just search COI service worker, and this one is going to be what we're looking for. And we just want to find this. We could use the minified one, but I actually want to be able to read the code. And so I'll just do the raw on that file, copy that, and create my source. I'll create a file. Actually, I'll just put it in public. And I'll call it coi.js. And I'll paste in that content. And then in my index.html, I can add a script. But for the beginning, I'm going to actually leave it commented out. So it'll be another script defer, except it won't be a module. And the source is going to come from /coi.js. Just pull that from the public folder. So I'm just going to serve this as a static JavaScript file and pull that in. Comment that out, save. And if I go to the application tab under service workers, you can see that just having it there for a little bit actually registered the service worker. So I'm going to unregister it, and I'm going to hold down the control key and hit reload so that I get an uncached version of this page. So I'll just call this the SQLite demo. And if I wanted to, I could do a bootstrap icon just to make things look a little bit better in the favicon, but it's not really important. So what I'll do next is try to check on cross-origin isolation status using the window.cross-origin-isolated or something along those lines. So in the app, what I'm going to do is check const COI equals window dot cross origin isolated if that equals true. I just want to be very, very specific. If this is true, not just if it's defined, but if it is true, if we are cross origin isolated, then COI is going to be true. So what I can do with that is say, for example, if not COI, we're going to return some main content, and we're going to say h2, because this won't be the title for the page, and we'll say security I'll say that cross-origin isolation is not enabled. Be sure that these two headers, which are coop and coep, so say be sure that the coop and coep headers are set by the hosting provider or a service worker. So that way we don't have any risk that we try to use SQLite if it's not actually available because cross-origin isolation is not true. I'm also going to create a loading variable. So for that, I'll use const loading set loading, or actually let's make it called db ready set db ready, and it's going to be false to begin with. And if db is not ready, if not db ready, we'll just return we can just return a paragraph that says loading. and we need to make sure to import use state from React. Just to make this look a little bit better, I will also give this a class of container fluid, and I'll give it a padding top of 2. That's just using Bootstrap styles for that. Now, yes, Vite could set these headers, but that's going to be unrealistic if we were going into a GitHub Pages environment, so I want to use this service worker instead. So in here, if the COI, like if we flip this and so it said COI, it's just going to say loading until something is ready inside of this DB ready variable, and so that way we can handle the fact that this database will take some time to set up, and therefore, you know, we don't want to try to do anything with the component before the database is actually ready to talk to. What I'm going to do to use the database is just take a look at this file. So they have an async function that is going through creating a promiser for this, which is just something that we're going to execute commands that are waitable. And so it's going to get the version of SQLite. It's going to open the database, and so it's going to do it with this protocol file. So it's not in memory, it's in a file. It's going to be called mydb.SQLite3, and this question mark VFS equals OPFS says that it's going to use the virtual file system of the origin private file system, which is yet another browser storage mechanism, and it actually resides in files on the computer somewhere, but they're not necessarily one-to-one mapping the same way that, like, if you use the file system access API, they would be. But the cool thing is that you can access those files from a worker and also from the main thread, which means that you could easily view and download those files to easily export your database. And the nice thing about SQLite is the database is just a single file. So you can access that from your main thread and then just download the entire database if you want to export it. And you could do the same for importing. You could just upload a database and overwrite the one with the particular name you want to use. So we can leave this MyDB, that's fine. It's going to get the database ID from that, and then it's going to just print something out and catch any errors, and it says your SQLite code here. So what I'm going to do is just create an object that I can export as the default export of this file. So I'll do export default, and I'll just make it an object, but actually let's do const SQLite equals, and it's going to have nothing in it to begin with, and then we'll just export default SQLite. And now this object reference will not change, but we can change the contents of it asynchronously. So down here, I'll just say SQLite.dbid is dbid and SQLite.promiser is promiser. And then this async function, when this promise resolves from this async function, then we know that the SQLite contents will be ready to use. To then export this function, I can just say export const whatever I want as the name of the named export. So I can call this like initialize SQLite is actually fine. So we can go in here and just import SQLite, the default import, and then we can also import named export of initialize SQLite from /db.js, and then we'll use initialize SQLite on the load of the component to initialize SQLite. So we can do a use effect, and we can give that no parameters, which means that when the component mounts, this is what's going to happen. And we can just initialize SQLite on mount. But of course, we don't want to do that if COI is false. So we'll do if not COI. So if COI is not true, then we will return, and otherwise we will initialize SQLite. Oh, and it's being called in this file, so we just have to make sure that's not being called until we decide to call it. And now to use this, we could also think about what happens when the use effect, when the component unmounts. And so that would be returning a particular function that's going to happen here, and that would be to close the database. And so we would only want to do this if initialize SQLite was actually true, or had actually been completed. So that would be something like initialize SQLite dot then, because the use effect can actually be asynchronous. And so we'll do initialize SQLite dot then, and we could say make a let the unmount function be just a function, an arrow function that does nothing to begin with. And then if SQLite was successfully initialized, we know that the promiser is going to be available. So then we could say to do this particular action, which would be yeah, I mean, it's checking if the promiser is there anyway, but essentially just to make sure that the promiser is defined. If the promiser is defined, then we could call close on the SQLite database ID. So just as another check, we'll also say and the database ID, then we will close the database ID. So we don't actually necessarily need that, since we have this if check and we know that the promise will be resolved if those things are true. So right now this is not getting run, but if we were to uncomment this or comment this out, and then it would try, it might try to close it, but obviously this is going to fail because we don't have cross-origin isolation. Then what does it look like for this to succeed? Like, how would we get that to succeed? Well, we come in and we comment in our service worker script, and we can see what happens. So to actually see what's going on there, it can help to, since the page is going to be reloaded by the service worker, it can help to actually preserve the log. And then I'll just hold down the control key and hit reload. And so you'll see what's happening is we navigated to this page. The coop and co-op service worker was registered. Then it reloaded the page to make use of the service worker because the initial headers were wrong, and so the service worker is going to send the correct headers on the next load. navigating to that page, initializing SQLite is coming from my code right up here, and then loading and initializing SQLite modules coming from the DB.js. Done initializing, running demo, running SQLite version 3.49.1. OPFS is available, created and persisted a database at mydb.sqlite3. So now in the origin private file system, it's created a file called this, and it's using that file. And then if the component were to unmount, hopefully it would close the database using the promiser's close. Now we're still seeing loading, which is deceptive. I'm going to turn off log preservation here, and it makes it seem like we're still loading, but actually we're not, because once the promise has resolved, so that when this then comes through, then we can just say that SQLite is initialized, sure, but we don't necessarily need that, and then set db ready true. And so now we're going to go all the way down to app. And so this, by the time we get to this app, if we've gotten to this means that we have cross-origin isolation, and the DB is ready, so we can start using it. And so I can say some main content, that this is the SQLite OPFS demo. Yes, it is running for persistent storage. Check the console for messages. All that's true. I'm also going to just take this down and say an H3 of test table data, and then I'm going to create a table, and I'm going to use Bootstrap to make that table look nice quickly. So use class table, and I like table, I think it's border, table bordered. Now we need some async functions that are going to do some stuff to get started. So when I set up the schema for a database, you for example, you need to create a table if it doesn't exist. So we could say, you know, write an async function that creates a simple users table with ID auto increment and name text if not exists. And we should end up with, it's a little longer than I was hoping for, but create a users table. Yeah, I'm not going to do these because by the time I'm calling this function, I want this stuff to be true. So I'm just going to say const promiser is equal to SQLite, which is in my global scope, and then I'm just going to not handle the errors just to keep things concise here for now. And there's a couple modes that I want to put on this this exec, and so I'm actually going to create an async function for exec specifically. So exec is just how we execute SQL on the database. So I'll make a function called exec that is async to note that it will return a promise, and it's going to await promiser exec, and we'll also pull in that DB ID, and then the DB ID can go here, and the SQL can come in from the parameter. And what I want to add on here is just a couple of settings that make it easier to get back the data in a good format from my experience, and to be able to pass in bindings as well. I'll explain bindings in a little bit. So you'll want to pass in bind, and bind is going to come from an argument as well. And you can set that by default to the empty object. And then you also want to set row mode. Row mode array can be good. There's also an object option. then you should set result rows. And this is just going to be an empty array, and that's like telling the software that SQLite that it should put result rows into an array, specifically this array reference most likely. And we can say column names as well, so that we can get those if we need them. So this is a pretty good minimal setup for exec. So we'll call promiser.exec, promiser exec, and then we can use our exec function here. We'll say exec, and here we're doing create table if none exists, ID, integer, primary key, auto increment. I don't know why there's an age here. I don't want an age here. And I'm also going to create a drop table. So that I can delete that and recreate it on every load for the testing purposes. Now, something that's nice to do when your schemas get very large for your setup, it's nice to centralize them in one place. Whether you're doing front-end databases or back-end databases, it's good to have some kind of schema. So I'm going to make a schema.sql file, and I can paste this in when I'm ready. And then the really nice thing about that is that Vite can support raw imports. So you can import the text of that file as a string and then use it. So I'll import db schema from /schema.sql (raw) to get that as a string. But let's continue with this in here in case we have any mistakes that need to be fixed. So I'll do async function insert users with an S. So we can just create some users. I'll do const bind equals, and this is where you can use $ names. $ is good because then those can be used within the SQL, and they can be known to represent a variable that then is going to be passed in. And so we can, since we did, we're doing binding of an object, it's easy to just set up what we want these different things to be. So we can do like $1, for example, like name1. Pretty bland names if you ask me, but we'll go with those. And then we can do promiser. Actually, we don't need promiser because we're just calling exec, so we can return exec, return await exec, insert into users. The name, since ID is auto incrementing, we can just pass name, and we're going to pass the values of name 1, 2, 3, and 4, and that should insert some names. And then we can do a select users would be good as well. So that'll be, once again, we can just call exec, so we don't need any of that actually. Just do return await exec, select, and there's also no need to pass in a bind because we're not binding anything. Yeah, I think they're over complicating this. Select star from users should be pretty much all we need. And then I don't need to delete right now, but I do want to make a test function, so I'll make it a sync function. Actually, let's make an async function. So async function test is going to await the drop users table, and I'll make sure that that drop table says drop table if exists. So yes, only if it exists should you drop it. and then I'll create the users table, I'll insert some users, and then I'll get some users, and I will return. No, this isn't really users, it's just going to be the result of the query. So I'm just going to return the await select users, whatever comes back from that. And this will be an async result. So I'll also make a sync version that takes a callback. So I'll do function test sync, synchronous, and I'll say on data, and that can just const data equals await test, and then it can just call on data. Oh, and yeah, of course it's synchronous, so you can't do that. So we'll just have data dot test dot then test dot then result. We'll call it D for data. D, and actually we could literally just pass on data. So we'll pass in what to do when the data comes through, and that'll help easily to integrate with the app here, because we can just say const data set data. So let's just do rows set rows, and then we'll have that set to an empty array, and then we'll wait for the initialization to be complete. We'll say that the DB is ready, and then we will do a test sync and pass in this callback of what is the data that comes through. I did not ask to do that. Alright, so nothing's coming through, so there's some sort of issue here. We might need some semicolons in here. Guess we should just make sure, just do something in test sync since that's being called, hopefully. Console.log it. So running test sync, and let's say, so await is not returning. We need to return await. That might solve the problems. Yeah, that's probably solving our problems. And then we're getting back this data object that contains result, and result contains our column names we asked for. It contains our result rows that we asked for. So that's pretty nice. And I could set the column names, but I could also just hard code them. So when that data comes through, we'll do const result is data, const result rows, column names is result, And let's just make sure that those look fine. Console.log result rows column names. Let's just do the latter two. So we get the column names and the result rows. So it's probably okay to set those. Set rows, set column names. And then in the table, we can just render out those different portions in different parts of the table. So down here we have the table. We can add a caption dot caption top, I think it is, to put that caption on the top. And then we can put our t head with our tr table row, and then th for the header in the head. So this is going to map each of the column names to a th with the key for React and then the content of the column name. And then in the body, we're going to map over the rows and create a table row, and for each row we're going to have to create different cells for each of the columns in that row. So this mapping is for these two things, and then the first map here is for each of these rows, and then the second map is for each of the columns within the rows. And then the styling is all nice just because of Bootstrap. And the reason that when we reload the page, and this all happens again, that we don't continue to add more of these is because we're dropping the table. If we were to not drop the table, you could easily see that we would just get twice as many, and every time we would do that, it would happen again and again and again. Now, I just want to show the power of this bind object quickly. So you may have wondered, why didn't I just pass the SQL in directly? Well, there's something called a SQL injection attack. And SQL injection is more of a concern on the server because it could lead to users getting data that they're not entitled to have, whereas this is a client-side database, so the client already has the database, so if they want the data that bad, they can get it. But it still prevents like weird issues from happening. So for example, if you were to put a select statement inside of your a form input or something like that, then someone could go like select users, select star from credit card data or something like that. So all they'd have to do is end the current statement with a semicolon and then say, yeah, like drop table users, or steal the credit card data from the credit card data table or something like that. So the cool thing about binding that SQLite provides and other database systems provide is that it's going to prevent you from using that. Even though this name is getting popped in here, it's going to run it through a sanitizer that's not going to let that SQL actually run. Whereas if we just literally put this text in here, we just literally put this into where name1 is going to go, then the SQL statement gets ended by a semicolon, and it throws off this whole statement. And so if something was put in here to make this correct, that could potentially even work and not throw an error, but it could drop the users table or something like that. So that would not be a good idea, and this protects against that problem. Another cool thing we can do here is auto-generate some data with JavaScript. So we could, for example, get const let's say 50 numbers is array from length 50, and I'm going to say const num rows so far is going to be object.keys. So the number of keys in this object above of bind.length. So how many rows? We have 4 here, but we could add more and it would update automatically. So the number of rows so far, we're going to add that to I plus 1 to get additional numbers. And then what we can do is we can do we'll make bind let bind, so we can change it. We'll say bind, use a nice higher order function here, bind equals bind dot reduce. If this is looking scary to you, don't worry about it too much. The point is we're going to pass in bind here, and we're just going to be able to continue to add things to bind. So to the accumulator, which will be bind, we will add name whatever the key number is and call that user key. And then here we're going to have an issue because we're only having these 4 names, so we also need to have a const values string, and this is going to be equal to object.keysBind.map, wrap it in parentheses, .join with a comma, and you can see how in here, now we're creating this ourselves, so we're not worried about SQL injection, and we can pass in that value string. And just to see what that looks like, console.log value string and bind object. Yeah, and this is not bind.reduce. This would be 50numbers.reduce. So now you can see we have a value string that has all of these different placeholders, and then we have an object that has data for all of those placeholders to plop in, and we can already see that all those users are getting added. So we have whatever 4 users we had, and then we add another 50. So we have 54 users put into there. And you can see how you could make all kinds of tools where you could have a user just press a button and have data automatically generated, for example. You could even use AI to generate the data also inside of the browser, and do a lot of really cool things by combining database technology that's been around for a long time with newer browser technology that's not quite as old. So I'm not going to go into more detail in this video about how to use SQLite, but essentially if you can run exec on a database, if you can execute SQL, you have the power of SQL at your hands now, and it's being saved in the database. The last thing to kind of keep in mind would be how can you get this data out, and for that you have to refer to the OPFS MDN API. And so this would be part of the file system API. And if we look for some code here, this would be something like the OPFS root. You can get a file handle on that and create it if it doesn't exist. So you could start out, or you could upload a file and put the data into OPFS on the main thread and then access it from SQLite. But let's just see how we can do function log OPFS contents. So we're just going to say const OPFS root is, I think this is right. This might not be right. Yeah, so this is what we need. OPFS root is equal to navigator.storage.getDirectory. So this is where you're going to get access to the origin private file system root. And then from here, you can get entries, and let's try doing this. And I'm just going to kick off this async function to let it do its thing. See how that goes. I'll stop logging these two things. Yeah, I didn't think it was get entries. I think would be essentially accessing the get directory. Will have a file system directory handle. And so this is going to have .entries. And that's an async iterator. So for await entry of OPFS root.entries, so we'll do key comma value, because it's entries of OPFS root.entries console.log kv. And so there you can see we're logging out on the two component mounts. We're logging kind file name mydb.sqlite3. So now if you were to say change the name that we're using here to like say like app.sqlite3, now there is the mydb.sqlite3 and the app.sqlite3, because this is creating a new one called app, whereas before it was just overwriting the previous database and continuing to use and open that same database over and over again. So you can see now how even though you can't view it easily in the application tab, it is there. And there's also an extension, I believe, OPFS Explorer, that you can add to Chrome, and then this will give you the ability to take a look at your OPFS. I think somewhere in here. Usually there's a tab somewhere in Chrome. You may have to restart Chrome. Oh, there it is, OPFS Explorer. And so now you can see that we have those two files. We can see the size on those files, and we could manually delete them, for example. And now app.db is being recreated by SQLite. And if we click save here, we could download that manually as we're developing the app to make sure that what's in there looks correct. But we can also do that programmatically just using the file system API. And that's where we're doing the navigator storage get directory, and then we have the root, and with the root we can list what's in there, and we can do a whole file folder structure, create, write, download, move files, anything we want. And then from the worker side, the file name that we specify will be the file that is opened by SQLite. So for example, if we want to import a SQLite database from another application, all we have to do is put it in OPFS and then the database, specify the correct name for the database, and it will open that database, and it's good to go. So I think that's going to conclude this video. To summarize what we've done, we created a basic Vite single page app using React and JavaScript. We added Bootstrap for styling. Then we added SQLite WASM, and we told Vite not to optimize the dependency for SQLite WASM. And then we, rather than having Vite specify cross-origin isolation, we used a hack to get cross-origin isolation to happen using a service worker. So we downloaded this COI script from a GitHub repository. We're serving it in the public portion of the repository, and then we're pulling that in on the index.html. So now we can conditionally render different UI states depending on what's going on, whether we have a security issue that's not yet resolved, whether the database is not quite ready yet, or whether the database is ready and we have data to show. We can render different things inside of the app. So finally, let's just push this up to GitHub so that we can see the hard work hopefully pay off. So I'll just create an app here. We'll put in the Vite config outdir of docs, and we'll do, that should be, I think, build actually, build outdir docs, and then we'll do base of SQLite OPFS if that's available. We'll make it private, since I have the ability to make private pages, sites. We'll do npm run build. Do an npm run preview. Everything worked fine. I'll hold down Control and reload. So I'll potentially have to reload when I land to the GitHub Pages site. And that might be a good thing to place inside of the inside of that message there. And that might be something that we can fix. I don't recall, but for now, just a message to reload the page should be fine, since that'll really only happen the first time somebody visits the site. So there we go. And I'll do a git add dot. Oh, do need to do a git init. Git add dot. Git commit dash m initial commit. Git push. And we are going to need to paste in this stuff. Reload. Now I'll do the pages routine of pages main docs save https code settings check save. Now whenever this is ready, we should get this link working. And what's the issue there? Did I misspell SQLite versus SQLite 3? So let's just fix that by changing the repo name. There we go. So just had to wait for things to refresh, I guess. Security issue, we reload the page and we get it. Now all the future times we come, we're not going to have to reload the page. It's just going to automatically work unless we were to start from fresh. So that's going to conclude this video. You've seen how to not only use the SQLite WASM package and get things set up, but also to publish that on GitHub pages and get around the cross-origin isolation issue so that you can save your databases to OPFS. And this is super powerful. It enables a lot more complex queries and things than you can do just with IndexedDB, because you get all of the power of SQL, the structured query language. So thank you for watching, and I'll catch you in a future video.